Hello everyone. Today I am going to discuss about the importance of circular economy and its linkage with artificial intelligence to achieve uh, SDGs. So let's go first. Let me introduce myself and my education and what my work experience. I am Anupam Trajuria. I am working as a researcher in United Nations Center for Regional Development, and I did my PhD in from Osaka University in environmental engineering. I had some experience as a postdoctoral researcher and as a researcher in India as well as in Tokyo Institute of Technology. So currently, I am working on in UNCRD with two projects, and the first project is based on the promotion of 3R and circular economy in Asia and the Pacific region. And in this project we are mainly organize some high level policy forums in annually, and based on this project there is one technical report we are working on it, that is the state of 3R in and circular economy in Asia and the Pacific region. Both projects are funded by the Ministry of Environment in Japan. And the third project is basically international partnerships for expanding waste management services. It is a platform for the public and the private sector. So I will go to explain a little bit about each of the projects. So let's start the presentation. So before going to discuss about how can I say artificial intelligence or circular economy. So let's start why we are talking about circular economy and why it is very important. So then we talk about the linkage with the SDGs and the circular economy and AI. So in the later part, I will give you the brief introduction of my organization and our activities. So I'm going to show why we are talking about circular economy. There are many types of economies. So later on we will discuss on that. So what's the reason of discussion? Because our waste generation in any areas of waste, like in electronic waste, plastic waste, or municipal solid waste, any waste is increasing in by the region wise. If you see this figure, there is in East Asia and the Pacific region, it's highly increased. So it's if you see the yellow line with the yellow projector, that is the 2050, it's expected with the future projection. So that is increasing really high. In the same correspondence, if the waste is increasing and if it is not properly treated and disposed, so there is a global treatment and disposal is also increasing, like the methods of different using methods. So in this method, if you see, the landfill is around 25.5%. However, the recycling rate is only 13.5%, which is really very low. It means that most of the waste goes into the goes in the other treatment technologies, but not as in the recycling process. So I think we should think about that part. And in the same thing, if the waste is increasing, then the economic loss and negative externalities happens due to the linear model. The linear model is basically we just extract from the raw material and we prepare something and we move the product and we will dispose it. So in that ways also it loss of the economic loss. So with this background, the waste is generating rapidly by using this linear model. In that same case, there is a economic loss in the mobility sector and in the building environment sector, because most of the waste is sent to the landfill, which is originate from not only the construction areas, any areas. And the third point is about the food, because food also that we are putting the food loss or food waste. This is also very high in that, like 25% in our global food waste is from the South and Southeast Asia. So To understand the various economies, so let's first talk about the linear economy. Linear economy is where shows it is a traditional economy model which flows from the take, make and dispose. This means that the raw material is collected, transferred into the product and then used until it's finally discarded as a waste. So there is no shift of the recycling in this process. And the second is about the recycling economy. In the recycling economy is basically after the product, some waste is tossed into the recycling process where we can earn the money, and some waste is tossed into the directly to the waste bins. However, in the circular economy sector, most of the waste is going into the regenerate that product again and again by the recycling method, or it also generate the money which relies on using the finite resource such as the metal, minerals, fossil fuels, and it also relies on the land and the water. However, the dumped waste is creating the pollution, but in this method it's not put the negative impact on the environment. So before goes to the circular economy part, so first understand the 3R, because 3R is basically reduce, reuse and recycle. Even now we are talking about many R's, recovery and repair. So many R's is going under the recycling process, but main concept is about the 3R. The 3R is basically the first R is happens to the reduce, the minimize resource consumption in the level of the basic need, because on the basic need we can think about how we can reduce the waste. And the second thing about the reuse for the products and materials that cannot be repaired or fixed, but we can use it again for other purposes. And the third part is recycling. Recycling is that like a process which being discarded into many products. So in this concept, the 3R is basically a substantial approach that can be achieved by to achieve the sustainable waste management, and it also contributes to the climate change mitigation in many sectors like waste, energy, transport, industry, in agriculture sector and land use sectors. So with this concept, the 3R is very much linked with the circular economy, and it helps to move towards the sustainable development goals. So understand this, the 3R concept is main foundation of the circular economy, because in linear economy we just take, make, consume, dispose and then pollute. So in this linear economy figure we can say that there is no chance we can recover the product again and we can reuse the product again. So there is no economic benefit in this process. However, in circular economy, even in the consumption part, we can use and repair and reuse the product again and again. And then after collection, we can recycle the products. So there are basically the three main concepts in the circular economy. There is no waste, the value is maintained, and it consider the economic framework conditions, because with the innovative technologies by using, so it not put the much pressure on the environmental sector. So in the same way, it's the promising sector for reducing the pressure on the environment and enhancing the security of the raw material and innovative technologies. So why circular economy is important? Because the circular economy is basically a framework with the three principles as designed, which can eliminate waste and pollution, keep products, material in use, and regenerate the natural resources. So it's based on the principle of the renewable energy and material. Like in actually the report we have mentioned here, and I am putting in the reference so you can have a look on that report, is basically in 2013. The first report is coming out by the Alan MacArthur, that is towards the circular economy, economic and business rationale for accelerated transitions. So in this report, it's clearly mentioned that like above I told in the beginning, there are three main principles, like in the no waste, eliminate all waste and pollution, even in the sustainable production step. So in the sustainable production, it can minimize the negative impact while conserving the energy and natural resources. The second step is about the keeping the product and material in use in the consumption sector, which can contribute substantially to poverty alleviations and transition to low carbon and green economies. And the third part is regenerating natural resources, right? Upscaling the products. So in upscaling waste from other industries and create value instead of sending into the landfill areas. So it's really important in at least in the three main concepts. So later on I will show you in the detail of the three main concepts. So mainly concept is about the production, consumption and distribution. So before going to technology part, we can manage at the distribution level as well. So in the production sector, we can redesign the product and rethink the product, so which helps to minimize the use of raw material and maximize the use of the product and component. And in the this sector, we can reduce and negative environmental impacts. However, in the consumption sector, there are three main sectors, that is recover energy, recycling, reuse and reduce. In this concept, there are collaboration is very needed for the societies, because we need to light up by the NGOs or by the private sector. We can contribute with the government and private sector both together. And the last point is about the distribution, where we can redistribute the product again, repair the product again, and remanufacture the products. So by using the new model with the contribution of the public and private sector. The third element, there are three main elements of the circular economy. The first one is optimize energy efficiency, and the second one is the way of the thinking, and the third one is think of cycles, how many cycles and how much closed that cycle. So optimize in the energy, or we can read about like a renewable energy, where the energy lasts as long as in the recycling process, because in the recycling process the raw material and product and energy is long last as in the recycling process, because the recycling process is fed off the renewable energy, and because it is only possible to the recycle energy, and there is no mention about that part in the mention of the loss of the energy. And the second is about the closed cycles, where the material cycle are closed, and there is no such thing in the waste, and because there is a very how can I say, residual stream can be used to make the new product. So there is nothing goes into the waste area, whereas the toxic substances are eliminated in the residual flow and separated into the biological and the technical cycles. So biological and technical cycle I will explain in the later part. So here I'm just saying that the materials can be closed and recycled properly without losing their value. So the way of thinking is like system thinking, because we need the collaboration in this process. We need innovative technologies to understand how the part of the system interact and produce the behavior of the product of the whole system. So that's really, I think these three elements are really important to come to flow the circular product in a circular economic way. Next is the innovative support for the transition of circularity. In this slide is like showing the steps involves the material meets the circular and eliminate there is no waste in that sector. So like a substitute material we can use as a reuse or recycle the product, or design the circularity by using the business models. And sustainable packaging is really, because the packaging we are using, like plastics most of the time, and which is not efficient product in for the environment. So like a bioplastic is one of the product, is best to use it. So the another is the closed loop, where the raw material we don't need to use again and again. So whenever one time we can extract the raw material, and then we can use that raw material again and again, and we can use the reform the product in that same raw material. And the next one is the low waste production, where there is very small amount of waste can be used and go to the how can I say, the like not even small amount product, or we can use the one of the waste from one industry can be used for the as an input for the another industry, is called industrial symbiosis. So there is no chance of the waste came out from the recycling material circularity. So this it is connected with the main four loops, and that is repair and maintenance, upgrade, and then reuse and remanufacturing and recycling. So basically this circular economy is an industrial system that is regenerative and regenerated by the design, which aims to keep the products and the components and the material as the highest value and highest utility and the value that in each stage of the product life cycle. The next is about the recycling rethinking process, circular rethinking process. It is I'm showing here, maybe you already know about the butterfly diagram. So I'm showing here the, like I explained, I've made it a little bit detailed why we are talking about butterfly diagram. So I'm showing butterfly diagram in the later part, but here I am making in the divide in the some parts to clear understand what is in the butterfly diagram. Basically there are two wings in the butterfly diagram. The first is biological nutrients and the technical nutrients, and basically the biological nutrients is represented in the green circle and technical in the blue circle. Basically it's the figure, it capture the flow of the material, nutrients, components and products while adding their any financial values. So which is the green is basically re-enter the natural world such as the biomass, and the blue part is such as the metals, plastics, so that goes to the technical nutrients. So this builds the long-term resilience and generate business and economic opportunities, and also provide the environmental and social benefits. So this loop of the blue and green, here I am showing the green is basically the biochemical feedstock or anaerobic disruptions, which ensures the enhance the flow of the goods and the services. And this system celebrates the continuous flow of the technical and biological, where the four loops which I showed you in the beginning, that is repair and maintenance and reuse, remanufacturing and upscaling, so that goes towards the technical nutrients. So this whole both blue and I'm not making blue in there here, so it's like blue and the green, it's both creates like a biological and technical nutrients is connected in somehow which can regenerative and restoring that by design and highest utility and the value of the product, even in the biological product or the technical products. So there here I am showing about the butterfly diagram. Here you can see, I'm not moving the more. Okay, here you can see the green part is basically by the collection from the farm biomass generation and regeneration towards the collection again the farming area. It flows with the renewable flow management, and in the blue side you can see the maintenance and reuse and recycle the products with the stock management. So it mainly based on the three principles. The first principle is serve and enhance the natural capability, by controlling the feedstocks and the balance in renewable energy flow. And the second one is the optimize the resource yield by recirculating the products. So that goes in both technical and biological nutrients to recycling and recirculating the products again and again. And the third one is the Foster system, which can effectively design out the negative externalities. Like in the beginning, I showed about the economic negative externalities, like in the mobility and the food loss and the transportation sectors. So same here, they are trying to reduce these things and design out the product in that way we can have no economic loss. So this transition of the circular economy is mainly based on the four scales. The first scale is about the designing the product, where we can facilitate the product and reuse and recycle. And in this sector, there is economic successful, so there is no loss of any value of the nutrients. And the second part is about the business model, because by using the innovative business model, either we can replace the existing one or squeeze the new opportunities. And the third one is about the reverse cycle, where we can put the final product of the material to the soil and back into the industrial process again. So this not like one way, it's like if the circle goes direct, and it also reverses the circle in the circular economy part. And the fourth one is enabling the conditions by the collaboration and financing from the private sector and collaborated with the government sector. So by understanding this circular economy, we have not missed main part, that circular economy is basically have the 5 main steps. So the first step is about the regenerating the economic, increasing the wealth of the green products and even the less toxic and long life cycle of the product. And the second is the reduce the resource dependency. So we are not depend upon the more natural resources. And the third one is the end of the life of the products. And the fourth is the minimize the waste as much as possible by separating the waste or reusing the waste. And the fourth one is reducing the environmental impact, which we can use of the less resource use. So this only it's a economic model basically, and it's possible by the involvement of the public and private sectors, such as we have one in the beginning I showed you about the project of IPLA, that is the public and private platform. And so I think the circular economy is basically an economic driven economy and is complementing with the governmental interventions only, because if the government have some policies and with the involvement of the private sector, they can achieve the SDGs. So it only brings the benefit from the beginning, like from the waste. It's like we can say, okay, waste is the end. It's not end, it's the beginning for the circular economy. So there are its opportunities for the middle and middle and low income countries, because it's not only we are dependent upon the other countries. We have owned all even one country have their own waste, and so they can regenerate that waste and recycle the product of their own country, and they can renew like a more economic wealth in their country. So the main opportunities of circular economy, there are many opportunities. I'm talking only the waste sector mainly. So if you see this, they have 2 main parts, as I'm putting in the green and the blue. That is the refurbish and remanufacture the product, and here is the redesign for the product like biodegradable product. It's helped with the cleaner production, industrial ecology, energy efficiency, and production life extension. So all these smart technologies, smart energy, and the cost also redesign the products also, it covers under the circular economy. So this is like the promotion of circular economy and the zero waste society, necessitates a global change of consumption and production pattern, actually, because if we change the global change of the global consumption and production pattern, so we can achieve the SDG 12, and we can do only with the possibility of the opportunities of the circular economy. And it also helps go well beyond the climate change or climate action. Then there are some challenges. Before I showed about the importance and opportunities and concepts. Now I'm showing there are some challenges in that part. In these challenges, there are mainly four things when we reduce or reuse the product, right? The product complexity, the value of the raw material, and the quantity of material, and the last one is the treatment, because there are some challenges in the chemical sector, because in the product complexity, if the product is less complex, then it is easier to reprocess the product, and the value of the raw material, because circular economy needs to operate within the economic boundaries, so we need to think about the value of the raw material which we are using in the product. And the third part is the quantity, because if we collect the product and centralize the end of the life of the product, so it's mainly based on the quantity of the product, how the product goes from the production center to the end of the life product. And the fourth part is treatment, because in the chemical sector, recycling and reuse is not enough, because we need really effective business models to do it, and it's really complex to manage the treatment of the chemical sector. So there is a bridge for the circularity gap. So the value of the raw material and the quantity and the product complexity is really main challenges mainly in the chemical sector. So I'm going to show you the two examples how the circular economy worked in that waste streams. So like in e-waste, like electronic waste. In electronic waste, you see this in 2018, there are around 50 million tons of electronic waste in all over the world. However, it's increased by more 50 million devices by 2020, because everyone needs work from, most of the people are working from home, so have their how they can work, because the office and the home is like, we can't go office because of the COVID situation. So it's like increasing the use of the products and more use of the electronic devices. And in 2021, it's increasing the 52 million tons. However, in 2050, it is expected to be 120 million. And in future, the consumption of raw material to make the product is said to be double. So we can understand by 2050 or 2060, the volume of the e-waste can be more by this figure is according to OECD. So they are saying by 2060, the world's consumption is double the sector value. So like including the PCs and laptops and the smartphones, the tablets. So most of that like 40 to 50% is total consumption, total emission of the product. So the carbon emission from these products are also increasing. So if the production grows like this, so we need to think about how we can manage that waste, whatever that come out. So in the circular economy process, the main part I am showing here is the EPR, that is standard producer responsibility. It is a policy approach that is under which producers are given a significant responsibility to the financial and the physical from the treatment and disposal of the post-consumer products. So like assigning such responsibilities to be in the principle providing like incentives to prevent waste and how can I say, promote the design, the product design, produce product design that is built for the environment process. Like we think about the environment, how we can build the product, rebuild the product again, and which can only support by the achievement of the or the involvement, I'm not saying achievement, there may be involvement of the public and private recycling, because the public recycling process helps to maintain and managing this tool, because EPR is not only possible by the, if government made some policies on EPR, so the private sector and the consumer also have to contribute in this process. So by this we can achieve the recycling economy in the case of the electronic waste. Another example I am showing to you about the plastic. Here you can see this is really increasing, and maybe you already have some in some science, business, maths, and they have their information that there should be more plastics than fishes in 2050. So it's all really increasing. By increasing this, that whole world is like 1 million plastic drinker bottle purchased every minute, and it leads to the 5 trillion single use of plastic bags. So from 1990s, it is more than tripled in the 2 decades, and in early 20s it is like more single time we have the single decade, we have more than 40 years the plastic wastes. So in manage to the plastic waste, we have to think about the recycling. This is really important, and to reuse the product. So all this packaging, all these things are coming under the plastic waste, or the circular economy process. Even in the mechanical recycling, or the chemical recycling, or the repackaging, or the collection and sorting. So in a circular economy, the plastic and the plastic products we can maintain their value by reusing, repairing, and recycling. So instead of linear economy, we should focus on circular economy or move towards circular economy. So how circular economy, what's in the chemicals? Why we are treating, like I show in 2 slides before, like there are some gaps in circular economy. Some gaps in circular economy in the case of chemicals. So here I am showing to you how it is possible we can create the clean circular economy, not with the dirt or with the it's not possible. So with the clean circular economy, we should signing out the toxic and problem chemicals. So here is, we should design out the hazardous chemical from the product, which is really not easy, but particularly dealing with the complex supply chain, which is really important. And another part, it should not go to the recycle some products, like in chemical sector all waste is not possible to be recycled. So the most effective way of recycling is needed in the concept of the circular economy in waste stream of the chemicals. So the circular economy is basically needs collaboration. So there are mainly 4 factors which are the key aspects of this collaboration. That is balance of the supply and demand side, because it helps to we should not extract more extract more natural resources for the manufacturing process. So we should balance the supply and the demand side. And the second is planetary boundaries. So if we extract more natural resources, so we affect our planetary boundaries. So we should think more about the transcendences with the planetary boundaries. And the third part is recirculation of energy and resources, because we are talking about the clean energy or smart energy. So we think about how we can recirculation of this energy and the resources by the 3R or the 4R or the 9R processes. And the last one is about the symbiosis. Symbiosis is basically cross-sectional implementation strategies. Basically, the symbiosis, we can have the collaboration with the private, public sector or private sector. So this is really needed by the for the circular economy, because symbiosis can be either as an industrial symbiosis, not only the public private but also the private sectors. So basically, it's not possible for by the one key person. So we need to think about all four key aspects for the requires for the achieving the circular economy. So circular economy is mainly generated by the four technical need. That is the innovative platforms. Besides this, it's innovative technologies. We need innovative platform to achieve where we can research on it. The second is the production of smart design, efficient material processing, and advanced collection, sorting, and recycling. So interactive platform is whereas the apps, websites, database I'm talking about, and support design for circularity is basically now we are talking about the repair the product or 3D printing and disassembling the products. And the third one is the efficient material process by the artificial intelligence, which I'm talking about the later part. And the next one is about the advanced collection and sorting by using sensors or robots. So this is only possible by without circular economy. I can say it's not possible without involvement of the without the using the platform of the technologies. So industrial revolution. Yeah, so I'm talking will show you the figure about industry 4.0. So let me show you the brief description about industry 4.0 or 4IR, why we are talking about, why we are linkage with circular economy and industry 4.0. Because industry 4.0 is basically is an intelligent networking of machines, where is many, you can see here there are many machines like artificial intelligence, robots, IoT, energy storage, cloud computing, biotechnology, 3D printing. So all this is undercovering with the industrial revolution, that is the fourth industrial revolution. So now we are talking about the society 5.0, but first we understand about the industrial 4.0. So industry 4.0 is basically is the collaboration compilation of many intelligent networking of machines. So there are the main four showing the applications of industrial technologies. There are 9 applications I'm showing to you here. The first one is advanced optics, where we can use the advanced optical and the numerous integral sensors we can use in that optics with the standard device. And the second is additive manufacturing, which is by the 3D printing particularly process, and the augmented reality, which is for the maintenance and logistic part. And the fourth is simulations of the value networking, horizontal and vertical integration, and industrial network, that is industrial IoT also, and cloud computing, where all machines, all the what we can do the analysis on it. And the last is a cyber security, and the last one is big data analysis. So I'm showing here just there are many other applications. So I'm showing here the 9 applications here. So in that 9 applications, we can work on how we can do with the artificial intelligence. So what we need, how intelligence work. The first is artificial intelligence is work with the data collection. So first I'm showing here the 4 very simple steps. The first one is the data collection, either perceiving the video or audio or visual or image in any form of data collection. Then the data engineering can work on it, and we can arrange the data in the readable form. And the third part is refining that data, compiling that data, and converting into the new trained model, which can be used by the human intelligence. And the fourth one is the design based on the logarithm, because we have some output concept. So based on that, we can use that functionality and use the pattern and use the solutions with the robot, so we can make the decisions based on the logarithm output. So these mean four very basic concepts to how artificial intelligence works. So there are mainly four areas have the potential applications for this and artificial intelligence's work. The first one is the redesign and redevelop the circular products where it needed, and the second one thing to develop the circular infrastructure and innovative technology, and the third one is enabling innovative models, and the fourth one is increasing traceability, because we really need to know the product, how can I say, in the processing we can have the defective part, so how we can trace that part. So basically it is supposed to be play an important essential role in enabling the circular economy, and artificial intelligence is enhancing and facilitating the circular economy innovations across industries in mainly in these four areas. So how we can unlock the circular economy opportunities by using the AI? So there are mainly three. I'm going to show you three steps. First is design the circular products, and the second is the business models, and the third one is the optimize the infrastructure which can ensure the circular products. So basically AI is the capable have the capabilities to have the AI is capable to build circular economy at a faster rate than the world is possible, I think, in without AI. So AI is really can be boosted or developed, then design new circular products and new business models. So I'm going to share here, there are 4 to 5 examples in different areas. So first is the waste sorting, waste management areas where we can use the waste bin, that is e-bin. And the second one in the agriculture process, there is the data on the weather or fertilizer or the past harvest and from the satellite. So that is helps to maximize the use of the farmland and other sources. And the third one is the transport sharing, which helps to matching the vehicles and vehicle types with their demands and the price and optimize their routes as well. And the fourth one is about the green and the renewable energy, which helps really increase the energy production and mainly increase energy production in the clean energy. And the fourth one is the AI in water, where we can detect the fault in the pipelines by using the AI machines. So how AI can unlock with future, how we can unlock the future with AI? So that is basically machine learning, artificial intelligence. It mainly helps to eliminate most such of the need for the manual labor and maximize the use of the resources. So I'm not saying that we can cut the manual labor. So we can manual labor, that is cutting the cost basically. So it is like, for example, I can show you here. With this figure, we can see there are some green patches. Green patches is basically the item of the waste. So basically the waste, the AI machine can help to recognize the waste by definitely by adding the data which we add in the machines earlier. So this is like the item we can stand with the cameras and analyzed by the deep learning algorithm, and we can identify the waste from the outsource. So the benefit, there are some few benefits. So the first benefit about the infrastructure and the vision of the software. The second is the transparency by using this, and we can easily identify the better accuracy than the human power, and it's really real-time insight analysis, and it helps to detect the leakage, which I showed. This is basically, I'm showing the last figure which I showed you, so that how it's worked in the different different sectors. So AI can easily predict and analyze and recommend some actions which can help to attain the sustainable solutions. So I'm going to show here few AI machines. For example, drones to the supply vaccines in some areas, and there is a full floor cleaner cleaning machines. There's a service delivery machines and catering service machines. So there are some examples of the AI. So I'm going to show yes, AI can change in the healthcare sector. Actually, this example I am taking from Japan. So I have the same thing here. Actually, Japan is facing the aging society, you know that had in the cities. But there are countries is increasing their medical and social security expenses. So basically, one person can go for medical like for dentist or for eye checkup in different hospitals, so they have received the medicines receipt. But there is a solution by using this AI sector. We can see in this picture I'm showing you, there are one doctor can easily analyze, or person can easily have their record maintenance by using their machines to support how their medical checkups record, as well as the treatment nursing can ensure, and this is sharing the information within one device. So it's basically from remote areas we can put that service in the one sector. So giving the same example in the infrastructure sector, as the infrastructure sector, there are more manpower is needed, and where the problem happened, you need to say by the manually. But after the solution of the AI or sensors or remotes or robots, so we can use to inspect and maintain the roads, bridges, and tunnels. So this AI is really showing some benefits in our lifestyle. So there are some steps. I'm giving some example of India. So here, okay, this came very early. So I'm showing here how the circular economy moves in India. The first, in 2014, the government launched the Clean India, like the Clean India mission. And the second step, they are making the Still India, that is Still India campaign in 2015. And the same year, they are putting the Digital India. So how you can see this all steps from clean, still, digital, made in India, these all steps are stepping like initiative towards a circular economy in India. So it's not possible we can achieve circular economy. Okay, we are saying circular economy, but we have to think about how the government works and how we can involve the public and private sectors. So in these all four steps, all public and private sectors are involved. So steps towards the circular economy, for example. And the second is like there are some models we need to achieve the sound management of circular economy. Clearly, circular supply chain, because where we can focus on the single use or non-renewable products. So this is really a long-term product. It's the circular supply chain we need to think about, and the product lifestyle. Product life extension, that is demand of the high quality products which will reduce the use of the natural resources. And the third one is recovery and recycling, that is energy from the disposed product or the byproduct create a huge opportunities that can be utilized. And the fourth one is quality versus volume, that we should focus on selling function, that is quality rather than the amount and the volume of the product. And the last part is sharing. That is the main part I'm going to show on this. That is, artificial intelligence helps in the digital platform that can also optimize the reuse of the chemical products. Because in the last slides I showed you how there is some gaps in the chemical sector, but the sharing of this AI can be possible. We can optimize the reuse of the chemical products. So this helps to build the risk assessment and reduction and prevention of the illegal trafficking of the product as well as the waste. So this business model helps really to the sound management of the product on the each on any stream or any like the plastic or the chemicals, so that we think about it. The next part is energy, how we can link with the circular economy and energy efficiency, because I'm talking about the clean energy or renewable energy. Here I'm showing to help to reduce the carbon emission. For reducing the carbon emission, we need to think about the local products, or we need to think about the climate change. And when we reducing the use of the raw material, so we talk about reduce, reuse, recycling or circularity. And when we talk about the renewable energy, it helps think about the reduce the fossil fuel usage. So basically circular economy and energy efficiency is linked with each other, because the energy efficiency, renewable energy and resource efficiency, there are very familiar area of the policies in various countries. So these are topics are circular economy or energy efficiency. They are linked with each other, and it's embedded with the current policy, that is main ingredients of the current policy makers, that helps to achieve and work on it and move towards the sustainable and circular economy society. So I'm showing here, we are talking about the circular economy, but now I'm showing to there are some other sectors of that, how we can recirculate the products. So one is the bioeconomy. In bioeconomy, that is the value added from the biodiversity and the cultural base. And when we talk about the circular economy, that is mainly based towards the zero waste. And the third one is the green economy. Green economy is basically reduced GHG emission. So all or any type of economy that is will contribute towards the SDGs. So not only circular economy, there are more economies which helps to add value, which helps to this circularity into contribute towards the SDG in any form. So in the title you can see the circularity to relate sustainability and SDGs. So here I am showing to you there are more approaches which helps towards the circularity and sustainability and finally achieving the SDGs. Here there are many like regenerative design, performance design, or cradle to cradle industrial ecology, which I discussed in the beginning, like industrial symbiosis, or blue economy, which talked about more on the water area, bio-based economy, more on the agriculture area, so donut economy. So all these economies, all these design or economy or cradle to cradle or usage of commercial or industrial process or the closed cycles, these are mainly related to the circularity sector, and it move or affects or not affects, it's a move towards the SDGs. So how it helps to achieve the SDGs. So not only the one, there are many others. So now I don't have time to discuss with you one by one on each. So maybe if I have chance some other time, so I will explain of each have their own role on goal, so we can discuss if we have more opportunities to talk on this. So now I am moving towards here we talk about the sustainability, and as your course is mainly on the sustainability, so let me talk about a short description about the sustainability. Why we are talking about sustainability? Because sustainable development is basically the meet and the needs of the present without compromise the ability of the future generation. Like what we have now, so we should use it and also we should preserve it so that we can meet their own needs for the future generation. So basically it started in 1986 by the Berlin report, and it's made we have many agendas, many concepts And in 2012 there is the future we want, and then I've been in the MDG, Millennium Development Goals, and in 2015 we're talking about the SDGs, that is Sustainable Development Goals. So I'm going to show here more in the later we will discuss more about the SDGs. And even in the beginning we are talking about the circular economy or AI, but it's the step to achieve SDGs basically. So sustainable development is hardly convinced without many three steps basically, that is moving from the prominent linear economy and towards a constantly circular economy, and simultaneously cutting back to the on the overconsumption of the product, because we are consuming the overusing the many raw material, as we are only extracting the raw material, so we are not thinking about what we have left in the last, so we should think about that. And it rapidly reducing CO2 emissions. So we should think all these sectors how we can make the environment green, because in this figure I'm showing also the pollution and in all sectors, so we should think about how we can achieve the sustainable development. So in that sector, achieving the sustainable development, circular economy or SDGs is one of the step ahead. So understand the circularity in various economy, like in the previously we talked about the fourth industrial revolution, or I mentioned about the society 5.0. So why we're talking about society 5.0 or fourth industrial revolution? What is the society 4.0? We discussed about society 3.0, society 1.0. Is there any society like that? So let's me give you the short background. In society 1.0 society or society 1.0 is basically human hunter society, where human beings live in a society in which for the food to obtain and collection and gathering wild animals or plants. So the second in the society we had agrarian society, where is mainly basically we focused on the agricultural society, and the third one is industrial society. That was the phase we only discussed about the industrial or the production and technologies. And fourth in society is 4.0, which I showed you beginning of the AI or industrial revolution. Basically, it's the information society, that is the use of the technologies. But in the fifth society, society 5.0 is basically ultra smart society, where AI exists not only in the fourth industrial revolution or industry 4.0, it involves in the society 5.0, because AI is combination of the machines and with the exceeding the capabilities of human behavior. So it's like a combination of the how can I say, the society is connected with the cyber and optimal result. So now we are talking about society 5.0, where we can achieve the good results and we can maintain our environment clean, healthy and green. So now we talk about SDGs. SDGs is basically our Secretary General mentioned this, quoted this sentence, that SDG development goals are to-do list for the planet that will transfer the world. So basically we have the 17 goals. So now I'm showing to you the detail, and all goals are very specific, measurable, attainable, relevant, and definitely it is time bound. So time bound I am saying because these goals is basically 2030 agenda, we can say. We are saying that 2030 agenda for sustainable development goals. So we are really running now we are in 2021, so we are very few years left so to achieve 2030 agenda for sustainable development goals. So these goals, they have like 17 goals, and including 17 goals there are 169 targets, and now I am defining about 169 targets in different 4 categories. like how many targets in the government sector, how many targets for the public sector. So for the national government, active role targets is 135 targets. However, the government of the regional and local government, that is 110 targets, and there are 88 targets is mainly their active role, need the active role of the private sector. And the national and international cooperation, like organizations, they need cooperation, so that is need 54 targets are active for this role. So basically there are 17 goals, which include 169 targets, and in targets there are 239 indicators. So that's why I'm saying it's measurable, attainable, and very specific and relevant, because it involves all four sectors, but it's the time bound, so that we need to think about. So all SDGs are inherently linked, even though, because if we talk about SDG 12, there are some targets or some indicators are highly linked with SDG 14, that is the how to clean this, land, sorry, SDG for the life on water. So that is really linkage with each other. So now I am showing to you how why I'm saying that SDG inherently linked. There are two SDGs I'm showing here, SDG 11 and SDG 12. How it is linked with the waste, because SDG 12 we are thinking about responsible consumption and production. Okay, it's very linked with the waste management sector, but SDG 11 there are some indicators or some goals are very linked with this SDG 12. So SDG 11 is basically sustainable cities and communities. Here in target 11.6, which says that by 2030 reduce the adverse per capita environmental impact of cities, and including by paying attention on air quality, waste management, municipal and other waste management. So that is the point I am talking about. Here, indicator 11.6.1 in target 11.6, this is clearly mentioned about the proportion of the municipal solid waste collection managed in controlled facilities. But this is talking by the cities. Here in SDG 12.5, we are taught about the reduction of waste management, prevention and recycling and reduce. And in indicator 12.5, that is national recycling rate, tons of material. Here is the tons of material recycled, not only the plastic, for example, the plastic, that is a material and that is consumed by the cities, by the public, so to make clean the city. So that is how is all SDGs are linked with each other. So it's not only for the one actor responsibility. We have to collaborate with public, private, or national, or local, or regional, or international organizations to contribute together to achieve all SDGs. So here I'm showing you about the 5 P's. If you realized in my first slide when I show the title, I showed that figure of the 5P. So I'm showing here, I'm going to explain here what is the 5P. That is a structure around this 2030 agenda for sustainable development goals. The first P is for the people, that is determine the end poverty and hunger, and around 5 SDGs are covered under this. And the second P about the planet, that to determine the product to protect and the planet from the degradation, and around 5 SDGs are covered under this. And the third one is the prosperity, that ensure that all human beings are enjoy prosperous and live full lives. So around 5 SDGs are covered under here. And the next P is about the peace, where is determined to foster peaceful, justice and inclusive societies. And the last P is for the partnership, that is mobilize the means required to implement this agenda. So basically the partnership P is the platform for all the P's. So if we do the partnership part, so we can achieve rest we can step ahead towards the rest of the P's. So basically this 5P is the how can I say, like maybe the fruit or the one plant, that is plant if there's some leaves, like economic and environmental and social aspects basically. So without these P's, or without the thinking of the economic, environmental and social aspects, we can't think about of any of the P. So all are linked with each other. So we have to achieve to clean our environment, or social impact, or economic impact, or so we think how to can move towards to achieve the SDGs. So I showed you about the circular economy concept and figures, how we can work on it, and this is a step ahead towards the SDGs. So here I'm showing about as the circular economy is basically work as a toolbox, because if we have to achieve SDGs, so we have to think some toolbox how we can work on it. So SDG is basically the blueprint to better and more sustainable future for all to achieve. It is like which I showed you in the 5Ps, and with the three aspects, that it economic, environment, and social aspect. So this is like we have something to achieve, and circular economy is basically the approach for achieving this local, national and global sustainability. So these two are really linked with each other. So SDGs are strongly and directly benefiting from circular economy practices. SDGs are indirectly benefiting from circular economy practices. SDGs are facilitating the uptake of circular economy activities. So the approach of circular economy help were really necessary to achieve many as the targets, or many targets underlined outlined by under this SDGs, like for example SDG 11 or SDG 12 and many more. So now we are moving towards the last part of our lecture or presentation today, that is about us. That is, I'm going to show about what UNCRD is doing. What is UNCRD basically? Actually, UNCRD is United Nations Center for Regional Development, and we are based in Nagoya, Japan. So our vision is to achieve sustainable living environment for all, safe, secure and equitable development in harmony with nature. So basically we harmonize under three core elements, that is economic growth, social inclusive and environmental protection. That is the same we are talking about in the 5Ps, that is in environment, economic and social impact. So we are working on the three complementary areas. That is, the first is the indirect regional development planning, and the urban management, and the knowledge management. Urban planning, urban management of like sustainable urban management and knowledge management. So let me show you about our project. So basically and yes, UNCRD is established in 1971. It is based between the agreement between the government of India and United Nations to strive and promote the sustainability regional development in developing countries. Definitely with the focus of the development planning and management in the concept of globalization and decentralizing networking. So we have like basically the four projects I'm talking about here. We have like first is integrated regional development planning, where we use to multi-scalar to cover environmental impact and economic issues. And the second one about the waste management and SDG partnership. So this is basically I'm working on this area. So where we can promote the 3R and circular economy in Asia and the Pacific region. And also our aim is to foster the partnership among local authorities, private industries, international organizations and many more. And the third one is disaster management planning. So this project aims to foster partnership to support effort to achieve SDG, sustainable development. And the last one is about the transport sector. So in here we had one project on environmental sustainable projects. So basically environmental sustainable transport, sorry. So basically the two, waste management and environmental sustainable transport, both our projects are covered under the environment unit. So I'm working on the waste management. Sometime I contributed also on the EST, that is the environment sustainable transport sector. So all these our 4 projects are very much a reflection on the SDGs, like SDG 6, SDG 11. 6 is basically we talking about in promotion of the 3R and circular economy. 11 we also talked about in the waste management and also in the transport sector. And SDG 12, this is basically on waste management, and SDG 13 also cover under waste management, SDG 14 also waste management sector, and SDG 15, and I'm not showing here many more, but there are many more SDGs we are had reflection in our projects. So in our 3R waste management projects, we have one conference on the in 2013 we had Hanoi 3R declaration. Actually we prepared some declaration where have some goals and indicators. So in let me give you some background about this Hanoi 3R declaration. So this Hanoi 3R declaration is basically sustainable 3R goals for Asia and the Pacific region, and from 2013 to 2023. And this declaration is adopted by the participated member countries during the 4th regional 3R forum. And this declaration have 33 goals. And 33 goals, there are 4 goals is based on the municipal and urban areas, 5 goals in the industrial areas, and 2 goals in the rural and biomass areas, and 5 goals on new and emerging wastes, and 17 goals on the cross-cutting issues, equity, education, gender, data, and information. So actually this declaration is adopted in 2013, that is before SDGs. So but most of the goals are very much linked with our SDG goals. So somehow it is related with SDGs goals as well. So recently we launched a book on the state of plastic waste in Asia and the Pacific, issues, challenges, and circular economic opportunities. So this book is I'm going to show you here a small description. That is, this book is discussed about the DPSIR framework. Maybe you know about driving force, pressure, state, impact, and response, and also discussed about the material cycle of the plastics and state of the plastics and its pollution and its impact on the plastics. So this book we launched in last year 2020 during the 10th regional 3R forum, because last year we had online forum. So I contributed in this in this book. So, and also I'm not showing you the many that we have many declarations, so I'm not showing you all declarations or all time out reports from our all projects. So I'm giving here only the very highlight for the two things I highlighted here, and some take-home messages I have. The first one is the policy making. The take-home message is basically implementing SDGs by using circular economy or 3 Rs, 9 Rs. So policy making actually implement effective policies and enhance retention and extracting natural resources, and it definitely promote economic development. So we should think about really suggest or make some innovative or implement some effective policies. The second one is redesign. By thinking about the circular economy, it definitely moved towards zero, even in the poverty or waste and emissions. It is really difficult target. Indeed, with the possible with the redesign the product, that is moved towards the circular economy. And the next is the technology. More actions are needed, like to need to adopt new technologies, because we are habitual to use with the linear sector, and we have technologies need learning process also. So we really think about uh, how we can adapt with new and innovative technologies. And the last is the balance between the like to maximize the recovery and recycling the product and protect our health and environment. So one more key message I want to review, that is not necessarily key message, that is like open invitation. We are also doing encouraging the students for the internship. So if anyone is interested to do internship in our organization, so please contact us, so we can give you the guidelines how you can apply for the internship, what is the process. So basically now, because of the COVID-19 situation, I think now it is getting better. So maybe instead of the online internship, maybe going to be the physical internship or face-to-face internship, we can say. But mostly nowadays, because of the COVID-19, it's like online internship. So please, if you are interested, please contact us for internship. And it's like 2 or 3 phases of internship. So please have a send us message so we can review the detailed description of our admin staff. So thank you. And the last, thank you very much for giving me this opportunity. And thank you, Professor, for giving me these opportunities to talk about today. And I think everyone, including students or including many like us organizations or any universities or academics or private sector, like every small count really matters. So let us protect our environment. And thank you very much. So here I am giving to you some reference material. Actually, this is the main very few reference material which is from the related based on the circular economy and industry 4.0, and the report which I mentioned you, which we launched. So please have a look on it. So thank you very much for today's time and your thank you very much. Thank you.